Hey guys, what's up? This very session is for a topic, which is again from the biomolecule, like most of you know. And I'm talking about, structure, and it's called HOWARTH structure. What this HOWARTH structure is, before I even come to that HOWARTH structure, I have to repeat something from the previous lecture. I did help you, doing those two structures. Which are called Fischer, projection of glucose. And however, the only difference between Fischer structure and this HOWARTH structure is that Fischer structure is, like a, backbone kind of arrangement, right? You have a backbone and there are some, nerves coming out. So these nerves are represented there as bonds where OH and H are respectively present. Now, that cyclic structure, that hemiacetal cyclic structure of glucose is much better, when it is expressed in terms of the HOWARTH structure. Why HOWARTH structure was discovered, why HOWARTH structure was, developed, I'm coming to that, but before that, let me help you how this structure is made, right? So this is going to be again very short one and very useful one, and at the same time, very simple also. So a glucose molecule, as per the HOWARTH structure, can be represented, like if you remember, I told you that this should be represented, something like cyclohexane, So I'm just drawing a cyclohexane here. This is your cyclohexane, right? Most of you know. And I'm again doing, the same structure. This is also another cyclohexane I'm drawing. And why I'm drawing this way, because I have a really poor sense of drawing. Probably most of you know. So these are the two cyclohexane. Now what you need to do, you have to place one oxygen right here. So this is like this. So this is your oxygen here. Similarly, one oxygen is here. So that oxygen is right here. Now, if you remember, this carbon is first, this is your second, this is your third carbon, this is your fourth carbon, and then you have this fifth carbon. So, what in the HOWARTH structure is, it has the first, on the first carbon, first carbon, the OH is on the down way. I've already explained why this happened in the previous lecture, but right now what I'm doing, I'm trying to make you go and I'm trying to make you remember how HOWARTH structure is is written. So on the first one, the OH is down here, H is up here. On the second one, again the OH is down and H is up there. On the third one, the H is out. However, the OH is inside the ring. Again, remaining, carbon has OH on the outside, down way, H will be on the up way, and this fifth one is having a CH2OH, like this. This is called your beta D glucose. This is called your beta D glucose, right? This is your beta D glucose. Another thing, let's talk about this one. If this is your first carbon, then what you have to do, OH should be placed up here. OH should be placed up here, H right here, and all other things going to be just like the original structure. So let me complete this. This is going to be H out here, OH in there, and then you have OH here and H up there, and this one is similarly CH2OH. Now what this is called? This is called your alpha D glucose. Alpha D glucose. Okay. Now pay attention, because right now, this is something you have already done, probably 80% of what I just did, but let's talk about the very important part here. Both of these glucose have almost everything similar. What is different here is the configuration around the first carbon. You know, the first carbon in the beta has OH on right on the down way, while in the alpha it is on the up way. So this is the only difference you see out here. Now let me explain you the theoretical part here, which is very important. You know, these two structures, the beta 1 and the alpha 1, they are like 99% similar to each other. The only difference is that the first carbon configuration is different. Why? Because the first carbon here in the alpha has OH on the down way, while the beta has OH on the up way. And any such molecule, let's pay attention. Any two or more compounds which are also the isomers, if they have a difference if they have the difference of configuration at the first carbon, such pair of compounds are called anomers, right? So this is coming out to be a very important term. Let me write this, what I'm saying, anomer. So just pay attention, this is going to be very important. Anomers. This is also called epimers. This is also called epimers. Epimers. Now what this is, let's make it in writing. Isomers of a compound, isomers of a compound having difference at the first carbon only, at the first carbon only. So any two such molecule where you see that the configuration of the first carbon is different, all such molecules are called anomers, or they are also called epimers. So these are the two glucose forms, and these are also called anomers here. Now get back to the get back to another very important thing, and this is about pyran. So what this pyran is and what this pyran has to do with these two structures, right? So I'm drawing this pyran right here. You know what? Pyran is a structure like this one. So what I'm doing here is that I'm drawing again a hexagon here. So this is again a cyclohexane, but the problem is that one of the atom here is again occupied by the oxygen like them, and there you have two double bond here. So this very molecule is called pyran. So this very molecule is called pyran. And if we look at these three structures, what we see that these are also, 6-membered ring where 5 carbons are in the ring with one of the oxygen. So because of structural analogy with pyran, let me repeat, because of the structural analogy with the pyran, Howarth, called these two structures, pyranose structures. So the two, glucose structure, the two cyclic hemiacetal structure of the glucose, they are analogically similar to this pyran, so they are also called pyranose structure. So these alpha and beta, these are called pyranose structure, right? Okay, let me do this in writing, what these three structures have in common, right? So the thing I'm doing, is pyranose structure. So just pay attention, this is again something important coming up. Pyranose structure. And what this is, the two structures of glucose, two hemicyclic structure of the, or simply two hemiacetal cyclic structure of glucose are also called pyranose structure. So these two pyranose structure. right? So these two structures are also called pyranose structure because they are structurally similar to a molecule pyran. So Howarth, Howarth came with this idea that the two cyclic structure of the glucose have something to do with this very molecule structurally. So that's why these two structures can also be called pyranose structure. So Howarth structure is, this is, something I wanted to make you go. I hope you have, understood every part here. Let me repeat back. In the beta one, the first carbon OH is up here and everything else is similar. In the alpha one, the first carbon OH is on the down way, and that's why these two form of the glucose are also called anomers. Just pay attention here. These are also called anomers, or they are also called epimers. What? So epimers, anomers, these are similar term where two isomers of a compounds are different because of their only first carbon configuration. And what difference is right here? One is having OH on the down way, other is having OH on the up way. So with this I must complete this, and I hope to see you in the next lecture. Till then I would say good night and take care.